There are so many people in the world who struggle with getting sleep or staying asleep at night, and I run a podcast that helps bore people to sleep. I use my voice to read Wikipedia articles to help people calm down and get their minds to shut down is really probably the biggest thing. So what I'm going to do today is help you try an alternative method to medicine or other things that maybe aren't working for you. And let's just try listening to my voice as I read Wikipedia articles. Now, this one is actually a really interesting one. It is a wiki book about control systems. Now, that sounds really fascinating to me, but I anticipate that this is not going to be that exciting. Let's go straight to the introduction and the table of contents and tone down the lights just a little bit, and let's get started. This book was written at Wikibooks, a free online community where people write open content textbooks. Any person with internet access is welcome to participate in the creation and improvement of this book. Because this book is continuously evolving, there are no finite versions or editions of this book. Permanent links to known good versions of the pages may be provided. What are control systems? The study and design of automatic control systems, a field known as control engineering, has become important in modern technical society. From devices as simple as a toaster or toilet to complex machines like space shuttles and power steering, control engineering is a part of our everyday life. This book introduces the field of control engineering and explores some of the more advanced topics in the field. Note, however, that control engineering is a very large field, and this book serves only as a foundation of control engineering and an introduction to selected advanced topics in the field. Topics in this book are added at the discretion of the authors and represent the available expertise of our contributors. Control systems are components that are added to other components to increase functionality or meet a set of design criteria. For example, we have a particular electric motor that is supposed to turn at a rate of 40 RPM. To achieve this speed, we must supply 10 volts to the motor terminals. However, with 10 volts supplied to the motor at rest, it takes 30 seconds for our motor to get up to speed. This is valuable time lost. This simple example can be complex to both users and designers of the motor system. It may seem obvious that the motor should start at a higher voltage so it accelerates faster. Then we can reduce the supply back down to 10 volts once it reaches ideal speed. This is clearly a simplistic example, but it illustrates an important point. We can add special controller units to pre-existing systems to improve performance and meet new system specifications. Here are some formal definitions of terms used throughout this book. Control system. A control system is a device or a collection of devices that manage the behavior of other devices. Some devices are not controllable. A control system is an interconnection of components connected or related in such a manner as to command, direct, or regulate itself or another system. Control system is a conceptual framework for designing systems with capabilities of regulation and or tracking to give a desired performance. For this, there must be a set of signals measurable to know the performance, another set of signals measurable to influence the evolution of the system in time, and a third set which is not measurable but disturb the evolution. Controller. A controller is a control system that manages the behavior of another device or system using actuators. The controller is usually fed with some input signal from outside the system, which commands the system to provide desired output. In a closed-loop system, the signal is pre-processed with the sensor's signal from inside the system. Actuator. An actuator is a device that takes in a signal from the controller and carries some action to affect the system accordingly. Compensator. A compensator is a control system that regulates another system, usually by conditioning the input or the output of that system. Compensators are typically employed to correct a single design flaw with the intention of minimizing effects on other aspects of the design. There are essentially two methods to approach the problem of designing a new control system: the classical approach and the modern approach. Classical and modern. Classical and modern control methodologies are named in a misleading way because the group of techniques called classical were actually developed later than the techniques labeled modern. However, in terms of developing control systems, modern methods have been used to great effect more recently, while the classical methods have been gradually falling out of favor. Most recently, it has been shown that classical and modern methods can be combined to highlight their respective strengths and weaknesses. Hopefully that gives you a taste of what this podcast can do for you if you are struggling with sleep. Come check out the podcast on any of your favorite podcasting platforms, including here at YouTube. You can subscribe to the channel and get all of the episodes that I publish and make available to listeners. Happy sleeping.